Bismillahirrahmanirrahim. We shall continue inshallah today with Algebra 1, Chapter 11. Today we're going to talk about solving radical equations. Now, if you recall, this would be a radical expression, 3x cubed y. And this would be a radical equation. So this is a radical expression, and when you add an equal sign, that becomes a radical equation. And this is what we shall learn today, inshallah. And if you had something like this, in which you talked about already, y equals square root of x, this would be a radical function. And as a review, we have talked about radical functions, and the parent radical function was this, y equals square root of x, and we have graphed that radical function, and the graph of the radical function looks like this. And then we had also previously elaborated on this, and we have suggested the general equation for all radical functions was like this. And this is very important. So that's the general equation for all radical functions. We've also previously talked about simplifying radical expressions, and we had learned these two rules. Square root of a times b equals square root of a times square root of b, and the converse of that, square root of a times square root of b, equals square root of a b. Along this line, we also had this rule, square root of a over b equals square root of a over square root of b, and the converse is also true. Today, inshallah, we'll talk about solving radical equations, which is, alhamdulillah, it's not a very difficult topic, inshallah. So if I have a simple radical equation, if I say square root of x equals 5, okay? What I'm saying is I have a number here, and I take the square root of that number, I get 5. Okay, what is this number? I think you can imagine that number would be 25, correct? Because if I take a square root of 25, I get 5, correct? So the way we solve radical equations is by getting rid of the radical symbol, the square root sign. We have to manipulate the equation so we get rid of the radical sign. And the way we get rid of a radical sign is actually by squaring both sides like this. Okay? Because when you square both sides, okay, then you get like this, square root of x times square root of x. That's what this means, square. And 5 squared means 5 times 5, which is 25. And when you square root of x times square root of x is simply x. Okay? The reason for this is, of course, square root of x times square root of x is equal to square root of x squared, right? Because you can bring them under the same umbrella from the rules that we had just reviewed. And square root of x squared is x. In other words, a convenient way of getting rid of this radical symbol is by squaring the quantity. Okay, so x, the square root of x squared is x. So the square neutralizes the square root sign, so it kind of makes it disappear, and all you're left with is the x. Okay, so the way to neutralize, so to speak, the square root sign, or to get rid of it, is by squaring. And that's the basic concept of this lesson, in that the way we solve radical equation is by squaring both sides of the equation to get rid of the radical symbol. Okay? So let's try some examples. So a simple example then, square root of x is, okay, let's say 10. Okay, in this example, just like the previous example, I'm going to square both sides like this. And I square root of x squared, that will negate the symbol. So this will basically get rid of the symbol. So then I get x equals 10 squared is 100. Okay, well, let's take this a step further. Now I have square root of x minus 2, the quantity, square root of x minus 2. Let me try to write this neatly. X minus 2. Okay, all of this is under the square root sign, equals 10. Now this question is very similar to this question. I just added this 2. Now what do we do now? Well, we do the same thing. We square both sides, like this. Then we get, so this square root neutralizes or kind of makes the radical sign disappear, because, as I said, square root of something squared is just that something. Okay, that's how it is neutralized. So this, then I get x minus 2. That's what remains over here once you get rid of the square root sign. Equals 10 squared is 100. Okay, so then I have x minus 2 equals 100. Okay, then I just add 2 to both sides to solve for x, and I get x equals 102, and that's the answer. You can check this, of course. You can substitute this in over here. Let's do that. So x minus 2 equals 10, and substitute 102 minus 2. Does this equal to 10? 102 minus 2 is 100. Does the square root 100 equal 10? And that is correct. Okay. Now, so we did this example, square root of x equals 10. And then I did this example, square root of x minus 2 quantity equals 10. Okay, now I'm going to do a very similar example. Okay, watch this one. Square root of x minus 2, okay, plus 3 equals, all right, 103, I'm going to say. Okay, now, if you recall, I put this little, you can write a squared symbol like that, and that's perfectly all right. Or you can write a squared symbol like this with the little, like that in the end. I do this for emphasis purposes to suggest that this is the end of the square root. To emphasize this 3 is not part of the radicand or whatever's under the square root symbol. So this little hook in the end is for emphasis. Now in this case, how do we solve this equation? Okay, you might say, well, let's just square both sides like we did before. Okay, like this. I meant to say 13 over here, just to make math easy. Okay, so you might have said that, well, let's square both sides like we did before. Okay, no, that's not what we do here. Okay, what we do here is, okay, first we get rid of this 3, okay, because it's not a good idea to square equations with the radical signs, okay, unless the radical sign is all by itself and there's whatever is on this side. Because if the radical sign, like in this case, is attached to something else like this, and then you have something over here, and then you square this, then you have to FOIL this, and this is a bigger mess. So you don't square both sides of the equation until the radical sign is isolated. Okay, in other words, it's all by itself on that side of the equation. So you have to get rid of everything from this side of the equation and isolate the radical sign, radical symbol, and then you square it. So first thing we do here, okay, is you get rid of this 3. So you subtract 3 from both sides. That was supposed to be 13 after correcting it like 10 times. Okay, so I subtract 3 from both sides, like this. So then I get square root of x minus 2 equals 10. See? And now I square both sides, like this. Okay, then I get x minus 2 equals 100. And then I add 2 to both sides to solve the equation. I get x equals 102, like that. So the idea is to isolate the radical symbol, okay, and then you square it. before, if you square it before then you have to actually FOIL, and then you don't get rid of the radical symbol. It makes it harder actually. Okay. So let's try some more examples. How about this one? 10 equals square root of m over 10. Now we're supposed to solve for m. Well, that's easy enough because you can see here that the radical symbol is already all by itself. So you just square both sides. Okay, like this. Then you get 100 equals m over 10, right? Because anything square roots, right? No matter what it is, it will just get, let's call this, a. We'll just give you a. It doesn't matter what a could be a fraction. Okay? The way to get rid of the radical symbol is by squaring both sides. Okay? And now we have to solve for m. Just multiply both sides by 10 like this. Okay? Then you have m equals 1000. Okay? So that's that. Okay, let's do another one. How about this one? 6 equals square root of v minus 2. The same thing here again. Square both sides. So you get 36 equals v minus 2, and add 2 to both sides. And you get v equals 38. Okay? Alright, now, how about this one? So 10 times the square root of 9x equals 60. Okay? What do we do now? Do we square both sides like this? Okay. No. Just like before, you want the radical symbol all by itself before you square. So then you have to get rid of this 10, see? So what you do is you divide both sides by 10, like this. Because of multiplication sign, you can do that. So then you get square root of 9x equals 6. Then you square both sides. And then you get 9x equals 36. And then you divide both sides by 9. X equals 4. Okay, like that. So again, the key point is to isolate the radical symbol before you square both sides. Now I'm going to do some more examples. Let's do this one. Square root of 3n plus 12. Okay, so here I want to make sure that I bring the 12 under the umbrella of the radical symbol, like this, equals square root of n plus 8. Okay, so this is under the 8 umbrella. Okay, like this. Now look at this one. This was interesting because it has a radical symbol on both sides. Okay, but if you observe both radical symbols are isolated. There's nothing attached to them. Okay. So what do? Well, we square both sides just like we did, because then you get rid of radical signs on both sides. Then you get 3n plus 12 equals n plus 8. Easy as that. And then you solve for n. Okay, so you subtract n from both sides like this. So you get 2n plus 12 equals 8. Okay, and subtract 12 from both sides. And 2n equals minus 4. Divide both sides by 2. N equals negative 2. Okay? I did that correct. Alright, so there we have it. So if you have radical symbols on both sides, you can square as long as you isolate the radical symbols like that. Let's do another one of this kind. Square root of x plus 8 equals to square root of 3x plus 8. Same thing as before, we have radical symbols on both sides, you just square them, just kind of like make things so easy. So then I get x plus 8 equals 3x plus 8. I subtract x from both sides because you want the variables to be together. And then I subtract 8 from both sides. I get 0 equals 2x. And I divide both sides by 2. And I get x equals 0. That's okay. 0 is a number. It's a legitimate, honest-to-God number. So the answer is 0. Okay? That wasn't so bad. Right? Now, we'll do a little bit more advanced equations. See if I could find some examples for you. Watch this. Now, what if I have equations on both sides? Okay, watch this. What if I have something like this, okay? Square root of x plus 2 plus 3 equals square root of, I'm not going to do it this way. I'm making this up, so I might make a funny equation here. So square root of x and then plus 3. Now look at this. This is different, see? See, this is different in because here you have a radical symbol on both sides, I agree. But this side is not, it's not isolated, right? So what do we do now? Because if you square this, it's going to be a big mess, okay? Now, if you have radical symbols on both sides, if you have radical signs on both sides, the strategy is the same. The strategy is the same. The strategy is to isolate the radical symbol and then square it. Okay, so isolate the radical symbol and then square it. Okay, so but we have to first isolate them. So in this case, you can't isolate both of them. Okay, you can't isolate both of them. So you have to isolate them one at a time. One at a time. So this one is already isolated, so we're good. So we can square both sides. Because that way, we'll get rid of this one, okay? We'll get rid of this one. So then here you get x plus 2 equals. Now here you're going to have to be careful. Because here you're going to have to FOIL. Because this is going to be square root of x plus 3 times the square root of x plus 3 like this. Okay? That's cool. We can FOIL. So first, which is this times this, that's going to be square root of x times square root of x, which is just x outer, plus 3 square root of x inner, plus 3 square root of x, and last, plus 9. Okay? Then we get x plus 2 equals x plus 3 plus 3 is 6 square root of x plus 9. Okay, well this works out kind of nice for us because I can subtract x from both sides right away, see? And that's gone. I get 2 equals 6 square root of x plus 9. And then I subtract 9 from both sides. I get negative 7 equals 6 square root of x. And I divide both sides by 6. Okay. I get negative 7 over 6 equals square root of x. Alright, now look at this. Now I have the square root here all by itself. Then I can square both sides like this. So that becomes 49 over 36 equals x. And that's how we do it. Okay, you should check these in there and then make sure you did it correctly. But that's the way we do it. And I'm going to try to see if I can locate some worksheet on this. solving radical equations with radicals on both sides. Let's see if we could come up with something like this. Okay, let's see. Let's see if we can come up with a nice worksheet. Radical equations on both sides. Radical equations, other radical equations. Okay, let's try this. Okie dokie. Oh, this is all. Oh, this is a good one. Right, let's try to do this one actually. 3x plus 2 minus square root of 2x. So square root of 3x plus 2 minus square root of x minus 2 square root of x equals 0. Okay, now we're going to solve this, okay? Now, in this case, okay, you should not, the way to do this is you have, remember the idea is to isolate the radicals. You can't square this the way it is because then it'd be a big mess, you have to FOIL again. So what you do is, in this case, you take the one of them to the other side. So you have square root of 3x plus 2 equals 2 times square root of x, okay? And then you can square both sides, see, like this, okay? Then you get 3x plus 2 equals, now when you square this you have to be very careful because then you have to kind of distribute that, okay? So then you get 2 squared, okay, and square root of x squared is just x, okay? That's 3x plus 2 equals 4x. Subtract 3x from both sides like this, and you get 2 equals x. That was not too bad, like that. Okay? So, well, that's what they got. So they checked it too. They checked it for us, so that's kudos to them. Alright. Okay, hope you're not getting dizzy here. So I'll try to go slow so you don't get dizzy. These are all the same way, actually. Oh, I like these. Okay. Now, what I'm going to do is, in fact, I want to find some more trickier problems for you, where you have radical signs on both sides. And what I'm going to do is, I'm going to take a break here, inshallah, because I don't want to waste your time, because time is precious for all of us. And inshallah, we'll continue from here. But before I finish, I want to review. So the way you solve radical equations, okay, is by isolating the radical, and so that you have the radical symbol all by itself, and then you square this both sides of the equation, okay, and then whatever's inside over here will be left without the radical symbol, and then you solve the equation that way, okay. And until next time, then inshallah. Assalatu wassalamu ala rasulillah walhamdulillahi rabbil alameen. Assalamu alaikum.